So now we have arrived at my favorite topic, how to develop loops. And the remainder of the course is all going to be about developing loops for various operations, which will progressively get more difficult. So how does this work? Well, we're given a precondition Q and a postcondition R. We know how to prove a loop correct. It's a matter of finding a loop invariant such that that condition is true before the loop starts, and then proving that if that condition holds at the top of the loop body together with the guard being true, if that then implies that the loop invariant is true again at the bottom of the loop, then we know it's true before and after the execution of command S every time through the loop. That was a matter of applying mathematical induction. And if we can then show that the loop actually completes, then we know that the loop invariant is again true after the loop is done, but we also know that the loop guard is false. And then if we can show that that implies the post condition, then we knew that the loop was actually correct. Now, how can we turn that around? Well, if given the precondition Q and the post condition R, we can systematically derive a loop invariant, then actually everything else is prescribed. What we're looking for then is a loop guard G, such that the loop invariant together with the loop guard being false implies R. So you look at the loop invariant, you look at the post condition, you determine what the guard should be. Then you go to the top and you say, well, I need to get into a situation where the loop invariant is true. So then you derive an initialization command SI. So that's a matter of deriving a simpler program segment. Okay, and then you can turn your attention to the loop body itself, and you know what the loop invariant is, you now know what the loop guard is, therefore you know what the precondition and postcondition for command S are, and then you can apply the techniques that you've learned so far to actually derive the command S itself. And then you're done. You have systematically derived the loop to be correct. Now, notice that there is a command that will always work in the loop body, skip. After all, if the loop invariant is true before you skip, it is true after you skip. And that's obviously not a very satisfying loop, because the loop does absolutely nothing. Most importantly, it never finishes. So, that's not an acceptable solution. So in summary, given Q and R, the name of the game is to derive the loop invariant and to force progress towards completion.